Hello, everyone. What I want to talk about now is the waterfall approach to software development, also sometimes known, people will talk about it as big requirements up front, or BRUF, I guess. The Engineering Software as a Service textbook talks about this as the plan and document approach. Um, they're all fairly synonymous. Uh, and it's an alternative approach to software compared to the agile approach that we've been using in MSci 342. And in particular, again, we've been using Scrum, which is a agile approach. We'll talk about some other agile approaches after I talk about the waterfall methodology. But this is sort of the classic nature, the classic process for software development. And in fact, I would say this is a process that's very common to lots of types of engineering. And so it's not a surprise that it was applied to software, but there have been some downsides to this approach. In particular, I think in general, teams are less successful with it. There's more issues. More commonly, teams run into problems with not being able to deliver software on time, so forth and so on, which is a large portion of why the software industry has shifted to agile methods, and which is why we teach the agile methods. There are still lots of people who use a waterfall approach. They are still successful with it. They still have failures, and people fail with agile as well. And just being waterfall doesn't make it wrong, doesn't make it bad. And there are domains likely where the waterfall approach really is somewhat required. I wouldn't be surprised if a lot of space exploration follows a very waterfall approach to software development. I wouldn't be surprised if medical devices might follow it as well. In particular, the need to document and show that you've covered all these requirements is often part of those processes. And while we sort of do that all in our approach, and we're not necessarily as systematic about it, and so there are domains that might require this more traditional engineering approach and actually benefit from it. Now, with that, let's get in and actually start talking about what it is, though. So, like what we did in this course, classically, you're going to start off with some form of interview with your client. You got to start somewhere, and so let's just say this is our starting point, and then from there, you go, and the next step is after you've had that interview, or maybe a couple, you might have had to talk to more than one person, but basically you sit down and you write a vision and scope document. And it's quite possible that only you or a couple other analysts attended this interview, and so the team is starting very, very small, and may very well not have the developers and other people there at this stage. And we're gonna, as I go through this, I'll eventually explain what each of these are in much more depth. But the basic notion of a vision and scope document is to capture the needs of the client, basically to lay out what the problem and perhaps the envisioned solution is going to be. That's the scope portion. What are we going to actually cover? The vision is, this is the problem, and we see like the potential is following. All right, from the vision and scope, after you've gotten your vision and scope document written, move on to creating a project plan. Again, another document. And a really big part of the project plan is coming up with a schedule for the project. All right, so there's a lot of figuring out what the tasks are going to be in the project, estimating the size and length of those, and scheduling everything out in the project. This is the way that we think it's going to be, and we'll get it done by this time. And again, now the team is likely getting larger at this stage. More people are getting involved. You're engaging them, trying to figure out and get some estimates about what's going on. Next, though, you and the other analysts or program managers or project managers, product managers, there's a whole bunch of people with these very similar titles who are going to try to figure out what it is that really needs to be built. And this is all captured in a large document called the Software Requirements Specification. And this document focuses on the behavior of the software. It does not have pictures of the software, but it says, a user should be able to do the following things. They should happen this quickly. They should, these are the properties of the system. So, and we'll talk about that there's both functional and non-functional requirements. Functional is observable behavior for the most part. So after you've gotten that done, you've written that big document, then you hand that document off to the developers, and they produce a design specification. And this is where they document how to implement the behavior. And so, again, the way that I like to tend to think about this is the document that will really likely, have, if it's a graphical user interface, is going to have a screenshot and saying, this is what it should look like. When a user clicks this button, this is the pop-up that's going to happen. It's going to say the following things. And likewise, you're likely to have all sorts of stuff on the internals as well. We plan to have this entity relationship diagram for the database. We plan to have the following objects. The objects will have the following behavior. We'll have these interfaces between the various components of the system. It can go to huge amounts of depth. This is how it's going to be implemented and built. The behavior says what should actually happen, but doesn't say how it will happen. This is kind of, I'll be able to do the following with it. This is how I'll be able to do that. Once the design specification has been written, then you get to work on actually writing, doing the coding or the programming of everything. Okay, so working from your design specification, you implement everything out. All right, then after you've done all of that, you move on to testing the product. And of course, testing is going to find bugs, and so the developers are spending their time bug fixing. So testing is going to find lots of errors, and this is going to get logged, and we're going to spend our time fixing them. After we believe we've gotten our bugs fixed, then we release or deliver the product. After that, everything wraps up with what is traditionally called a post-mortem. There are a lot of people who don't like that terminology because it's like after the death. We shouldn't be dying from this process. Just a quick summary, it's kind of like a big retrospective, but it's for this whole entire gigantic project. You might very well spend a full day or even more trying to diagnose and understand what went well and what didn't go well with the project so that the team can learn from that. So it's known as a waterfall. I didn't quite draw it as that. If I was to draw it as a waterfall, I'm supposed to draw arrows that go from one down to the next, and you can see a cascade of materials passing down from one step to the next step to the next step to the next step. There's a definite flow of what's going on here. Plan and document shows up as a really good terminology. Write a document, write a document, write a document, write a document. You know, and not just one. These can be huge amounts of material created, detailing everything down to because you're planning it all out. You're doing this big set of, you're like everything, you're figuring out everything before you commit to cranking out any code, before you go to implement it. So it's this big requirements up front work, all this stuff up front. Now, with this overall process, there are some key sort of ongoing practices that go alongside this, that show up at most of these steps, is that there is a notion of reviews and signing off. Okay, so you produce a vision and scope document, you're going to have the client review it, certainly, and they're going to agree or ask you to change it because you didn't capture things correctly. You're going to create a project plan. This has got estimates in it. You're very likely to have the head of development, you know, the software team and everything, and the software team agree, yes, if that's the project plan, we'll be able to deliver and meet those dates that we've put into that project plan. They have to sign off on it. Same thing as we go through each one of these documents, there's this notion of we've produced this document, you've got to review this thing, and you have to agree that this is what we've agreed to, okay? So it's especially true in all the documents, but we continue to have notions of reviews, both of code reviews here, but then, you know, this is in itself is testing is largely a review process in and of itself to review, did all the coding actually deliver on what was agreed to here? So it's a check on that. Now, critical also is to have involved in this process a thing called change control, where, as you might guess, if you're in the midst of building the system out here and someone comes along and says, wait a minute, we actually need this other feature, or we need you to change the way that feature works, you can imagine how disruptive that is. Or, you know, you find things even down after you're done with coding. Oh, now that we're testing it, we realize that wasn't right, that we need to change the way, it's not that there was a bug, it's, no, that's not what the customer really wants. We now realize that we need to change it. And it's basically, oh my goodness gracious, it goes back and it impacts so much stuff. So that one change, of which everything else might have been resting upon as our understanding, can result in a gigantic amount of rework. And the more changes that we have to change, the more that this project plan and schedule just goes to be fiction and no longer true, because that was based upon everything before it, and it drove all this other work. So how can we ever stick and get things done on time if we allow people to change stuff on us? Like, we can't get it done on time. We told you it would take this amount of time for this amount of work. You want to change? That's additional work. How am I supposed to get it done on time? So you implement change control. Usually have a board or a set of people, and any change to the specifications, the requirements of the system, or the design specifications, that requires these people to sign off, again, review and sign off that they agree that this change will result in the following changed, usually a change to the schedule, or we're going to change the scope of the project or this or that. But we can't we can't just let things change. It's all one big plan, and as you jostle it, you're going to screw up your ability to deliver it on time. And so you implement change control. So whereas what we've been working on with Scrum is, oh, yeah, we admit and we accept and we adopt that changes are going to be a fact of life. This process works to control, not by, moving with the flow of the system and the world that we have, and client wants something else, fine, we'll let the client have something else. It's just going to take longer. Client knows that. That's the name of the game. No, this is, you said you wanted this stuff. We are going to deliver it. You agreed to take it if we delivered it. If you want something else, it's like a new project or a new, we got to start over, or we got to add on something. It's got to be renegotiated, so forth and so on. So this is all designed to maintain control by being inflexible, not accepting changes to it. All right. So they are really, in some respects, contrasts to each other. But at the same time, I think it's pretty clear that you could see that, we know, like in an individual sprint, yeah, we have to plan. We have to figure out what it is that we're building. That's kind of true. That's very similar. We do have to build it and test it and make sure it works, and we deliver it to the customer. And at the end, we have a retrospective. One way certainly to think about Scrum is it's like you've kind of almost taken this process and scrunched it up into 1 to 4 week little projects, one after the other, but it's almost the same thing. It's just that you're positive that you fix things to a certain time period, and at the end of those time periods, you go back and you get back with the customer, you reevaluate things, you keep trying to run retrospectives and make the team better. You even are on a daily basis meeting, so it's a different thing, but in many respects, you can kind of see it as saying it's not a bad thing, but because we do the whole project in waterfall like this, this prevents us from adapting to change. If we could work on it in a little bit and a little bit and constantly deliver new value, we can shift the direction and change the direction of a project to adapt to the change. And that's what we're doing in Scrum. There are some other differences, and we'll talk about those in a bit.